Okay, so this is examples similar to section 5.3 on page 174. So here goes. Question 1, I'm going to do part C to D and C to E actually. And we're asked to use equation 5.6, which I have shown here. And you want to make sure you download the Excel document while watching this video so you can follow along. In this case, we want to use this expression here to calculate the probability of any one outcome of the following. So in the first case, 11 trials, 7 successes. The probability of success in each is 0.42. This expression in yellow here is really d2 raised to the power c2, which is the probability raised to the power x, which is what this first part of the expression calls for. The second part of the expression calls for 1 minus the probability raised to the power n minus x, which is what this is doing. 1 minus d2, which is 1 minus here, which is the probability. So we have found that, and we want to raise that. So we use the little caret, which is the shift function. Shift and number 6 gives you the little caret, raises the first part to the power of the second part. So we want to raise it to the power n minus x. So this is going to be b2, which is going to be our n, minus c2, which is going to be our x. So this expression here in green is the second part of this. And then to calculate the probability, we multiply the two expressions, which is done here. And we repeat that for the different numbers in D and E. For question 2, we want to find using equation 5.7, determine the number of separate outcomes for the following. In the first instance, 11 possibilities, 7 choices. How many ways can we get 7 from 11? A combination of 7 items from 11 items. And that is done with n factorial divided by x factorial times n minus x all factorial. Excel has a factorial function which I'll replace here and do live. FACT, and then open bracket, we want to find n factorial, so we click on n, and then this gives us n factorial. This expression is the denominator, which is x factorial, the factorial of c7, which is x, times n minus x, which is b7 minus c7, and we're going to find the factorial of that, so we multiply those two. So this expression gives us the denominator, this is the numerator. So then the ratio n factorial divided by all of this is found there, and we repeat the same thing for 2D, and we end up with finding that. Now part 3 is asking us to use equation 5.8, which again is here, to determine the binomial distribution for the following, and the numbers are the same, the n's, x's, and p's. And from this equation, if you look carefully, you will see that to get the binomial probability, you're multiplying the probability of any one outcome times the number of ways you can get that outcome, which is what we found in the first two parts. So here we're just going to reference those values. So this one, so again we reference the number of ways to do it, which is, if you look at this cell, it's F7, which is here, 330 ways, and the probability of each is going to be found in G2, and then multiplying those two will give you the binomial probability. We repeat the same for 3D. And also, number 4 is asking us to use a binom, this function, which is found in Excel, and that is calculated here for you, where binom this is asking us to input . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . the number of successes, which in this case is 7, the number of trials, which in this case is 11, the probability, which is 0.42, or in D22, and cumulative is typically 0 unless you want to find the probability of everything up to this number, but we want to find the probability of exactly 7, so we use a 0 there. Hit enter and you notice that this result and this result and this one are the same, even though we used a different method to calculate those. Alright, so take a look at it, click on the cells and play around until you have found what works. Question 7, part A, real quick. We have a dentist with 15 patients. Probability of seeing a patient that needs filling is 0.5. We want to calculate the probability that in this 15, 10 or more will need filling. Now, 10 or more means that it's a complement of 9 or less, and we can find the probability of 9 or less more easily. So let's do that first. So in green here, the binomial dysfunction of 9. Why 9? Because we're looking for the 9 patients or less. B28 is going to be the number of patients. B29 is the number of successes, the probability of success. And then we use 1 because we're looking for cumulative. So what this 0.849 represents is the probability that the dentist will see 9 patients or 8 patients or 7 or 6 or 5 or 4 or 3 or 2 or 1 or 0 who will need filling. It's a cumulative. If you notice the 1 here, if we didn't put the 1, it would tell us the probability of exactly 9. But with the 1, it tells us the probability of 9 or less. If this is the probability of 9 or less, then the probability of 10 or more is going to be 1 minus that. So that's what we found here. Did it in one step in the first instance here, but felt like it would have been a little more difficult to explain there, so I broke it down into the 2 steps. Alright, so take a look at the sheet that's attached, and if you have any questions, feel free to reach out and I'll be happy to help. Thank you.